Welcome to the Muxall Open IoT channel. I am your host, Michael Crane. Alrighty, so in today's video, we are going to continue with our custom thermistor for the Muxall Pro barbecue controller. And the calculator, I kind of left it where we had calculated it using the Stanford Research Systems thermistor calculator version 1.1, and I went ahead and did the Inkbird so I could remember how to do it. It's been quite some time since I've done this, so I thought, well, let me test one and then I'll video the eBasics / ThermoPro thermistor. And if you remember from the video when we were measuring them, we did, I think I called it generic, this eBasics, I'm down here, the eBasics probe, because I couldn't remember what it was. I dug it up on Amazon, and it's made by eBasics. It's compatible with ThermoPro. In other words, it's just a generic knockoff of a ThermoPro. Anyway, it looks pretty good. Here's the link for the Stanford Research Systems calculator. I can put it in the comments below if I remember. Anyway, so let's get started. We measured this in the previous video, so 32 degrees Fahrenheit. We measured everything in Fahrenheit. I calculated it to Celsius using the Google formula right here, and just kind of plugged it in here, and then I just filled in the ohms. So we measured Fahrenheit and ohms, but this calculator wants it in Celsius, the temperature in Celsius, so I had to convert it over. So we'll just go ahead and plug these numbers in here. So at 0 degrees Celsius, it is 326,300 ohms, or roughly 3.3 K. All right, and then at 71 degrees Fahrenheit, 21 degrees Celsius, we'll see. There, plug that in, and oops. I'll just put 21.67. All right. Let's see, so it was at 21.67 degrees Celsius, it was 114 K, 114.6, and at 153 or 67 degrees, 67.22 degrees, oops, it was 18.5 K. So 1851. Oh, all right. And as you remember from last time, we did this last time. I don't know what I did with Steinhart calculations. I probably saved them off, but I couldn't find them. Anyway, so here's our numbers. I'm going to double check these guys. 326,300. Yep, at 0. 114, 600. Yep, at 21.67. 18,510. Okay. And that's pretty nice. What's also nice about this little calculator, which I didn't realize until I was using it today, is a lot of times when you're speccing out a thermistor, you spec it out at 25 degrees C. And so if you come down here to this model calculator and just plug in 25.0, it'll tell you. So this is actually a 98.697, basically a 100K thermistor. So if you have a thermistor that's a generic one that doesn't necessarily have to be a ThermoPro, but at 25 degrees C it reads around 100K, this will probably work for it. It's not guaranteed, but it's a good starting point, right? Okay, and as you can see, this curve fits real well, so that's good. So we're basically done with the calculator there. I want to move this up here real quick, because I wanted to show you these guys right here. This is coefficient A, coefficient B, and coefficient C. And originally I had, you can see right here from the calculator, it gives it like 0.69 times 10 to the negative 3, and 2.2 times 10 to the negative 4, and 0.835 times 10 to the negative 7. And I couldn't remember if we could put in this exponent, so I went ahead and just took the 10 to the negative 3, 4, and 7 out. And the way you do that, in case you're wondering, is you can take this number And you don't have to do any counting. This is why I'm showing it to you. You can just plug this number in here and you say e to the negative 3, and Excel will magically convert it for you. Now, to make this happen, so if you put it in let me put it in another cell, like right here. So if I do Control V, and then I put e to the negative 3, you see it leaves it in that scientific notation. You don't want that, right? And if you're trying to get it broke out, trying to get that 10 to the negative out. So what you have to do is you go into Format Cells, and under Number, you format as number, and you just say, okay, I want 16 decimal places, and it will go ahead and break this out. Now, it'll put it back into scientific notation if you go past 16, but as you'll see, as you can tell, we didn't here below. So anyway, that's the way you can do that without having to count 7, 4, and 3 decimal places back, because it's very easy to make a mistake when you do that. Enough with Excel 101 stuff. I'm going to go ahead and copy these numbers out right here. I guess I should have just left them in there, right? This is just for my sake. All right. And as you can tell, these numbers don't have the exponent, so I'm going to go ahead and put that in here. E to the negative 3. E to the negative 4. Sorry. And e to the negative 7. Okay. And that's fine and dandy, but the next step we're going to do is we're going to plug this thing into our LTC2984 test bench program, for lack of a better word. It's called something that's like a demo thingy, but I forget what it's called. Anyway, one of the nice things about this, and I've done videos on this before, is you can put examples how you want to configure the chip, or the 2984, and then you can just say create C code. And you say select folder, okay, and it dumps it in there. And we're going to look at that here in a second. But what we want to do is we want to get all the numbers this thing generates. It's basically so they can handle negative numbers. They convert it using big Indian, little, I forget what they do. Anyway, if someone knows, they can comment. Anyway, it generates, to me it looks like random numbers. And they actually tell you how they calculate it if you go in here and want to read. I forget where it's at. Oh yeah, here it is. So it generates, yeah, these numbers, and it gives all this information and dumps these big numbers in there. This is how it generates the numbers. So if the value is 1.545 times 10 to the negative 3, this is a starting address. The positive and negative is right here. Here's the most significant bit. Oh, this is the exponent, then mantissa, and here's the most significant, least significant bit. You kind of plug this number into here. Then this right here is generated into a value that is plugged into a 32-bit single precision floating point format. That's interesting. I didn't know it was floating point. But anyway, and you can read this if you want. I didn't bother because this thing does it for us. And thank goodness it does. All right. So anyway, we're going to come into this Steinhart number channel 17 right here. And I've already got it set for custom thermistor with Steinhart coefficients. Oh, it's custom address. Well, it's showing 8 here, but we want 12, and I'll show you why here in a minute. I'm going to accept changes. So now we're going to come in here and put these values in here, right? Yeah, so we can put these in here, but I was reading in the manual, this guy right here, and it will actually take the numbers in that format. I want you to notice, so this is their example of custom values, and you see this is A, B, and you would think C, D. And that is actually true. That's how they set it up according to the manual, right? A, B, C, D, E, F. But there's a gap. But you notice there's a gap in this example right here. And I couldn't remember for the life of me why it was like this. This is why I was practicing on one, so I didn't sound like a blithering idiot when I was talking about this, because I just could not remember what happened when I configured this first time. If you look at my code right here, you'll see I have that 0 in there as well, right? Here's the inkbird I did earlier. So, and the reason for this, and this is kind of a trap, so you got to be careful with this thing, is this little calculator right here does ABC, e to the negative 3, e to the negative 4, e to the negative 7, right? And if you look at the little help, a plus b times the natural log of r plus c times the natural log of r cubed, and you'd think, okay, ABC, right? ABC here, ABC here, but there's that gap. And if you look at, so it's e to the negative 3, e to the negative 4, e to the negative 7, I think you see where I'm going with this. So if you look at the manual and look at their formula, it's a plus b times the natural log of r plus c times the natural log of r squared plus d times the natural log of r cubed. So here's your a, b, you skip c, and then d, right? And I know this is kind of confusing, and I'm probably doing a horrible job explaining this. But if you look at this equation, and you look at the equation right here, you can see it's negative 3, negative 4, negative 7. You're kind of going, well, how does this line up, right? And so they're using, well, I don't know. It is a little bit confusing, I have to admit. Sorry, I can't go off this to highlight it, but you can see it's a plus b times logarithm log of r, and then plus c times log cubed. If you go over here, you can see, okay, a plus b times logarithm r plus c times logarithm cubed. And that doesn't really match up with this. But if you read further down, the most general form applied equation contains logarithm of r squared term, but this is frequently neglected because it is typically much smaller than the other coefficients and not used. Is that clear as mud so far? Yeah, I'm sure it is. So we figured this out. So when we're plugging it in this guy right here, if you remembered what we were doing, I've almost forgot. We skip, where was it? Oh, it was in the code, right? Yeah, so we skip basically a C coefficient, we plug in the D. I hope I haven't lost, I'm sure I've lost everyone, but we'll move on. Okay, so good news is we can just plug these coefficients in without having to convert them. So what do I do with my calculator? Here it is. So I'm just going to copy this, Control C, oops, Control V, e to the negative 3, and then this guy, Control C, Control V, e to the negative 4, and then Control C, Control V, e to the negative 7. Okay, and that kind of lines up with their example, wherever that went. Yeah, so here's their example. So we got A, B, C is zeroed out, and D. I just wanted to show you this because it left me scratching my head for a while there. Okay, so we've got this plugged in, and we're going to say okay. This thermistor address, I don't know if I should go in this. I'll briefly go into this, but this is just memory mapping. It's got 6 coefficients. So we're starting at address 0, which is not really address 0, it's address whatever it is. And this is the offset. So this is an address offset, right? So we're doing starting at offset 0, and then this is offset 4. Is that right? Yeah, so it's sorry, I had to pull up the LTC doc again that we were looking at. Yeah, so it's 4 times the start address plus 4 plus 8 plus 12. This is different coefficients. So I actually had to go back and review it myself, and I actually did this morning. You'd think I would have remembered, but this little area and this little calculator is very confusing, and I'll try to muddle my way through it and show you. I ended up let me find my code just so you know. I actually did something like this. I said, okay, I'm just going to manually map it, and I was using the example. I was using this example right here. And as you can see, okay, so the start address is hex 250 plus 4, which is the length of the 32-bit length, right? 4 times 8. And it says start address, which I called index in mine because there was just too many addresses in this example. And okay, so you got coefficient A, B, C, D, E, F. So you've got 6 coefficients that are 4 bits in length. So 4 times 6 is 24, right? And so you have your start address at 0 plus, so anyway, you add 24, and that should give you your next address value. And so I kind of did this to make it easier for myself. So we're starting at address 250, hex 250 is correct. And you had 4, index 0, which is the first, what is it, a word? I don't know, 32 bits. And so you got address 250, 254, 258, and that falls in line with their example here, right? 300, 304, so 4, 8, 12, and etc. So I kind of did that for myself. This is a sanity check for myself. And the reason why I did all this is because when you, so here's our first one, thermistor address 0, right? You would assume the next custom thermistor address would have either been 6, because there's 6 custom values, or number 2, right? So you got custom address 1, custom address 2. And there are 6 values in length. I would have assumed it would have been number 2, and I think I tried that, didn't work. What helped me actually figure out what was going on with this thing is click on create C code. I've already done that. And thank goodness they add a bunch of comments in here. So here's our start address. Unfortunately, it's in decimal, but 592 is our 250. Oh, here we go. Yeah, so they got 6 times 0, which are 6 addresses. So there's no offset. So it's going to start at address 250. I hope that makes sense. So now you get down to the second one. So 616 is our starting address, and they calculated it as, so there's 6 coefficients that are 4 in length, right? So there's our 24. You add it to 250 and it comes up with, unfortunately, decimal 616. And if you plug it into your handy dandy little calculator right here, you can see that's 268. Right, so if you go to my code, or my little thing right here. So as you can see, so 4 times 6 does equal 268, which is 4. So here's the last one here. It's 264, last address, sorry, and it's 4 bytes in length. So now it's making sense. But what doesn't make sense, and I still have yet to figure out why this custom address. This is, I don't know. It should say length. I don't know why it says address. It's super confusing. And if you look in their example, actually, I think it does say custom length. Yeah, so I don't know. Anyway, to make a long story even longer, so yeah, watch out for this thing if you're using it, because this is confusing. And that's why I ended up doing this, just so I could keep it straight in my brain. What was going on. Luckily, the data sheet, kind of helps you figure it all out. So anyway, look, they even excluded C in there in the data sheet. So, where are we? So, so we plugged in our values into, I thought we just did this. Oh yeah, so custom address 12. Okay, so that's why I'm using 12, and that's because it's the 4th one in the code, I do believe. Let me double check that real quick. So we've got camp chef, Madrix, so 0, 4, 8. Yeah, so 12 will be the next one. And I'm just going to plug it into where I had number 8 plugged in. The custom address of 8, or whatever you want to call this. I know 12 is going to be next based on what we just discussed. I just need to plug these numbers in, which I could have swore we just did. In fact, I know we did, but I'll do it again. Maybe I closed it without. So e to the negative 3. E to the negative 4. We're going to skip C and plug in D. Oops. E to the negative 7. Okay. We'll accept these changes. We're going to use custom address 12 and whatever that means. And here we go. Let me find this guy. Oh, here we go. We're going to generate some C code. And, all right, select folder. Yep. All right. And it should pull up. Okay. Yeah, so here it is. 6 times 12. All right. And why are they all 0? Okay, I found it. Sorry, I pulled up the I pulled up the wrong one. Okay, so here we go. Okay, 6 times 12. Here's our coefficients. So yeah, all you do at this point, you just copy and paste this into the code, and of course we'll call this the what is this, the Thermo Pro. And that is it. Don't forget, you can support the Muxall Open IoT channel by donation using a credit card and PayPal, or by purchasing products at the Muxall store. Details and links are in the description under this video. Well, that's it for this video. If you liked the video, give it a big thumbs up, that helps, and hit the subscribe button, that really helps. If you have any questions or comments, post them in the comments under this video. Thanks for watching, and I'll see you next time.